Hey everyone, last week we worked on solving right triangles using trigonometry, but not every triangle is a right triangle. So today we're going to derive a formula for for solving a triangle that's not a right triangle. So I'm going to start out with an arbitrary triangle. I'm going to call this triangle A, B, C. Now, in order to keep track of everything, in order to not overwhelm ourselves with variables, what we're going to be doing is we're going to start defining triangles based on their angles. So we have angle A, so we're also going to have side A. We're also going to have a side B and a side C. The side is named after the angle it's opposite from. So across from angle A is going to be side A. Across from angle B is going to be side B, and across from angle C is going to be side C. We need to have this type of relationship because we can't just call things the opposite, the adjacent, or the hypotenuse anymore, because first of all, if it's not a right triangle, there is no hypotenuse. And that means everything's just a leg. There's just three legs, and for every angle A, there's two legs that are adjacent to it. There's not just one adjacent leg and then the hypotenuse. So there's no more opposite, adjacent, and hypotenuse in a non-right triangle because there's no hypotenuse. So this is what we're going to do. We're going to refer to our triangles with the angle name, and the side with the same letter is opposite in the triangle. So A is over here, across from B is B, across from C is C. So the angle is always opposite the side. Now, since I already have that drawn in, I'm gonna redraw this triangle. So we have A, B, C, A, B, and C. Okay. So, with this, we can't really solve it with what we have. We can't really solve it with what we have. But we do know how to solve right triangles. And any triangle can be broken up into two right triangles. All you have to do is drop down the altitude. I'll make it solid. It doesn't matter. It's a different color. And that altitude is just the height of the triangle, so I'm just going to call it H. So there's really two triangles that we have now. We have this right triangle and that right triangle. So I'm going to draw them separately. A, B, that's H, and that's C. This is only part of B, so I'm not going to label it. And I don't have a name for that point. And then we have the other triangle. That's B, C, that was A, that was H. And this is only part of B, so I'm not going to label it because I don't know how long that is. But we have these two triangles. But from these two triangles, we have sides H and C, and we have angle A. We don't have all of angle B. This is only this part. So that's not all of angle B. So even if we knew what angle's B measure was, we don't know what that is. Same thing with over here. We don't know what that is. But with angle A, we have the H is the opposite, the C is the hypotenuse. Hey, sine is equal to the opposite over the hypotenuse. And then we have the same thing over here. We have angle C, which is part of our original triangle. We don't know what the measure of this angle is. We just know that these two together make up that angle B. And then we have the opposite and the hypotenuse again, so sine of C equals H over A. Now in this equation, A is from our big triangle, C is from our big triangle, but H is not part of our original triangle. It's just something we drew in. So since that's not part of it, let's get it by itself. So we would multiply both sides by C, so H equals C sine of A. And then same thing here. H is not part of our original triangle, but angles C and side A are. So H equals A sine of C. Hey, that and that both equal H, so we can say C sine of A equals A sine of C. And this A over here sees a cross equal sign. Hey, that's my buddy A over there. I want to go over to my buddy A, so to get rid of a times A, you would divide by A. And this C wants to do the same thing, so divide by C. So these divide off, those divide off, leaving us with sine of A over A equals sine of C over C. Oh, that's cool. So the sine of an angle over its opposite side is equal to the sine of another angle over its opposite side. Unfortunately, this doesn't help us with B. So let's try and take this same exact triangle, that same triangle ABC. So we have our triangle ABC. BAC. All right. But this time, instead of drawing the altitude from B, let's draw the altitude from A. And I already used the variable h, so I'm just going to use the variable k here. So now we have two right triangles. We have two right triangles. One of them, it's A, B, this is K, and that's C. And the other one, it's K, that's A, and that's C. This is B. So this time, the angles that aren't disturbed are B and C. And we have K as opposite, C is the hypotenuse here. So that's still sine. Sine of B equals K over C. And here, sine of C equals K over B. K is the part that's not from our original triangle, so we can isolate K. Multiply both sides by C. Isolate K here, multiply both sides by B. And since these two both equal K, we can set them equal to each other. Well, this C sees its friend C over there. This B sees its friend B over there. So those divide off, leaving us with sine of B over B equals sine of C over C. But wait a minute. We already had that sine of A over A equals sine of C over C. So if sine of C over C equals sine of B over B, then that's true. And this is actually our equation, our rule that's going to help us solve non-right triangles. This is called the law of sines. So this is our law of sines. It's the sine of one angle over its opposite is equal to the sine of another angle over its opposite, and is equal to the sine of the third angle over its opposite. Now, obviously, if we're going to solve this, we can only take them two at a time. There's really three parts to this rule. It's usually written like this, but there's really three equations that it yields. You can do sine of A over A equals sine of B over B. You can do sine of A over A equals sine of C over C, or sine of B over B equals sine of C over C. All right? So whichever one you need to use, you have the information for, that's the one you'll use to solve. Now, if you look in each of these, it doesn't matter which one, there are 4 unknowns, 2 angles and 2 sides. 2 angles, 2 sides, 2 angles, 2 sides. So you need 3 pieces of information. You need 3 pieces of information to solve this. And in the next couple of videos, we're going to talk about the types of information you can have to use the law of sines. All right? So have fun. Take it easy.